it does the thing now. Ha, there we go. Now it's coming up. Me mute Google Chrome and send off the announcement that we are live. Okay. The message has been dropped. And we'll see how many people actually come. We'll get started at about 7:35. Give people some time to come on in. Hey y'all, welcome. We're going to be getting started in just a couple minutes. If anyone has any questions on any of the subjects we have covered so far, anything from variables, control statements, arrays, functions, classes, the whole shebang. We have done the whole 9 yards there. So I understand if we went a little fast, and I am always ready to go into a layman term breakdown of these weird terms. But if no one has any questions, we'll be getting started in just about 2 minutes. But I can start talking about some of the subjects we are going to be going over today. We're going to be going over, first of all, the singleton programming structure, which is not quite a structure. It's more of an ideology behind a type of programming pattern. That's the word I was looking for. The singleton design pattern is really useful in Unity because it helps keep data consistent between scenes, which can be a little bit tricky without singletons. So it's definitely come in handy more than once for me, and I hope it'll come in handy for you all too. So once we cover singletons, we'll be going over, and if time allows, we'll be going over structs and enums and lists. Lists we could probably dabble in the end. Kind of goes with arrays. I meant to cover them last week, but we here. Welcome, welcome. We're going to be getting started in just 1 minute. If anyone has any questions before we get started? Yes, no, maybe so. Okay. Without further ado, let's get into it. So, open up the project that we have been working out of. However, we're not going to be using our same old script because we're going to make this into a manager. So in order to create our singleton, we'll start with a clean script. It'll just make it easier, especially if you want to look back at this later on for an idea of how to do it. So go ahead, right click in your project, go up to create, C# file, and I'm going to call this game manager. Now, Unity does a fancy schmancy thing. Whenever you create a C# script called game manager, it will automatically turn into this like little gear symbol, just to kind of help differentiate it from your other scripts. Once you've created your game manager, I'm going to double click to open up into Visual Studio. There we go. So our game manager script looks pretty much like any other script we have dealt with in the past. Cool. We always start from square one. But for a singleton, let me go over a little bit of what the singleton does and how it does it. So a singleton is a class that you program in that it will never have more than a single instance ever in a scene. And we program that in so that when we are referencing this game manager, we know that it is the same game manager that we are always talking to. It's the same person, the same receptionist calling all of these files. We know who we are talking to. So, in order to do that, we're going to first need to add a variable. So we're going to add some space above our start function. And this variable is going to be a little funky. It's going to be a public static game manager instance. Now, I don't think I've gone over static as a modifier, so I'll go over the definition for that quickly. Static basically just means that any object of a class will share this same variable. So, going back to the example of car classes last time, if we created a, oh goodness, what do all cars share? We'll talk Tesla. Tesla's cars have an operating system that is downloaded into the car and can unlock different features. All of the different Teslas of that same type has the same operating system, and it communicates the same way. That's kind of similar to this, to static, in that if we modified a static variable of a class, no matter which instance of our class of an object that we are talking to, it is always referencing the same variable. So if I said to the Tesla, okay, add 1 mile to this variable, And then the other Tesla across the country, I say the same thing, add 1 mile to this variable. That variable will now have 2 more miles into whatever it had before. So yeah. So this public static game manager instance looks a little wonky because, one, it's a variable that references our script. That is on purpose. It is making sure that this script is always going to be what we are calling when we call our game manager. And it is only ever going to have one instance. But first, we need to code that in. So we're going to add in a function called awake. So the awake function is a little bit different than start. It's called when, well, as you can see, when the script instance is being loaded. So instead of the first time that, there we go, the first time before update methods are called, it is whenever the script instance is loaded. So a little bit nuance. Awake happens first before start anyway. So now we are going to have an if statement. This if statement is going to be what checks to see if there is another instance of a game manager anywhere inside of our scene. And what it's going to do is, if it finds that duplicate, it will destroy it. Okay, let me pull up my note just to make sure that I do this correctly, because I still reference the same script that I created a while ago. So I haven't had to write it myself in a hot minute. So what I'm doing here is just putting in the if-else structure. Now, inside of the if statement, we are, this is where I need to double check. Sorry, y'all. Pulling that bugger up. I should have had it up to begin with. My apologies. Here we go. Okay. So now, let me just throw a package that too many folders. So many folders. Okay. So what we are going to want to do, I'm so sorry folks, I can't find this stupid script. Okay. I'm going to do it off of memory. If we get a bug, I'm sorry. We'll take it from there. Okay, so if we're going to check if instance is equal to null. If it's true, we're going to set instance equal to this. Okay, let me explain that a little bit first. So we're checking to see if our instance variable has been initialized yet. It's going to initialize the first time that we create a game manager object, or an object that has our game manager script. So when that happens, so this is happening on the first time, we're setting our instance equal to this. This is a keyword that is basically just referencing the script that is running, the current script that is running, the current instance of the script instance. Now, say instance does not equal null. Well, if that happens, then we know that this is a duplicate game manager instance. And we don't want that. We want only one singular game manager ever. So in the else statement, we're going to destroy this .game object. I believe that is the like 99.9% sure that this is the correct way. The logic seems right. Now, when we have our game manager, a really cool thing happens with our game manager script. Let's go back into our choose your own adventure. And actually, first in game manager, we're going to put a dummy variable in here just so I can demonstrate what the really cool use of singletons is. Let's put in a dummy coin variable. So int coins, yeah. And this variable theoretically would keep track of the number of coins that a player has. Or, yeah, we'll keep it like that. In our choose your own adventure script, we'll just throw it into start. Just add some space there. We are going to type out game manager. Now, usually when we want to use items or use variables or use methods in another script, we need to have an instance of that script. However, because instance is an instance of the game object, and because it's a static variable, we can reference it directly. I totally didn't make it public, did I? I did not. So coins isn't going to show up immediately because it needs to be a public variable in order to be found. Or it needs to have a different modifier. I want to say it's like, no, I think it is. Yeah. So now when we go to game manager.instance and start typing coins, we can reference our coins variable without having to do diddly squat work from our game manager. So you can see now that the game manager helps us to be able to reference code pretty much anywhere. Now, with great power comes great responsibility. There is definitely such thing as overusing singletons, and generally in normal programming practices, singletons are frowned upon as global variables are generally frowned upon because there's a big possibility of messing it up. So like if you redefine coins as like 0, well, you've now lost the count of coins that you had before from accidentally setting it to 0. You can't get that back. So it's always good to be able to comment what each line is doing So you remember when you are referencing, when you are redefining what is held inside of your game manager. So, I don't know if we ever went over comments. Well, if we haven't, we can go over that quickly as an aside, because comments are super duper important. So, comments are lines in the code that the computer does not try to interpret or read. They are strictly for the programmers to be able to remember what certain chunks of code do. So, in order to make a comment in C#, it's just // This is a single or inline comment. You can put it on its own line and say hi, or you could put it at the end of one of your code lines. Like, say I want to story start. So that's super duper useful. But what if you want to do multiple lines of code in a comment? Well, you can just keep going. I forgot my comment line. Buh. Bleh. But that's annoying and gets tiring very easily. So there is a multi-line comments as well. And I use these whenever I'm commenting out code. So say you're working on something in your code and it's just not working, but you have to leave and you know that your teammates are going to be coming in later, but you don't want to give them all of the like thousands of errors. Hopefully not thousands of errors, but for this case, thousands of errors that you've been running into. You can just do a /* and then at the end of whatever you wanted to comment out, */. And bada boom, the computer does not read any code inside of this. It's also good to use at the beginning of your scripts to say, I am the author. Me. Jess Withers. Hello. But yeah, it's a common practice in programming, especially when you're working on multiple teams, to have a multi-line comment at the very beginning of your script to say, hi, I did this, this is the day that I completed it, this is what it was supposed to do. It's just nice, clean programming practice, mumbo jumbo. Singletons. We are done with our aside on comments. We have created our Singleton game manager. We've talked a little bit about how we can use it. When not to use a singleton. So, honestly, use your singletons sparingly. I always make my singletons a manager of a major part of the code. So things like audio, having an audio manager to manage all of the sound systems in your entire game is a good idea, because all of your sound will have pretty similar play this sound options. Things like cutscenes, having one script to control and manage all of the cutscenes in your game could be a good idea. Oh yeah, UI Manager is one that I usually use. I find it super helpful when I have limited UI systems. I would not recommend it though if you have a UI based game, because then everything is UI. And thus it would just be a game manager managing the game. Okay. So I think that's all on singletons. The hover description doesn't show on. Oh, I didn't know that the hover didn't show. Oh, I will be uploading the stream to our YouTube channel afterward. So, don't worry if you missed some of what we have gone over. I can also talk about anything like post lesson. So, yeah. The first part of today's Twitch Tutorial Tuesday was about singleton programming design principle stuff. I don't know actually like the formal name of singleton and whatever comes after that. I think it's just a design principle for programming. Anyways, yeah, so stream will be on YouTube. You are more than welcome to catch up on. Oop. I closed a dockable. It's fine. I'm sure it's fine. I use OBS all the time. Everything's fine. Anyways, yeah. So, singletons for managers, great. Singletons for any old run-of-the-mill script, terrible. Reason being, singletons don't die. Oh, that's what I was forgetting. I knew I was forgetting some part of this singleton, and oh, goodness, Jess. So, singletons are meant to go between scenes without dying, without being caught in garbage collection. That happens whenever you load in a new scene in Unity. So in order to enact this, we're going to add a new line under our if-else statement in awake. And it's a really simple one-liner. Don't destroy on load. With your parentheses and semicolon. Now, why is it giving me do not destroy there is no argument. Oh. This. Just to be safe. This.gameObject. Making sure that it knows that it's not destroying the game object of the script, and just not just the script. Because that would be a little awkward. Can't really do much with the script and no game object. Can't refer to that. So now we have a script that, when attached to an object, that object will transcend multiple scenes in Unity and be able to store persistent data. So all of those times where in Unity you had level systems happening and your score just wouldn't save, you can now have that inside of the game manager. Okay, so I think that's my whole spiel on singletons. I think. So now we'll get on to some of the more interesting and complex variable types / data types inside of programming and Unity, which will actually be quite useful in our game manager. So we're going to talk about structs. So structs are a type of data structure that is almost like a diet class. You can have variables in structs, you can have functions in structs. However, you need a variable in order to hold the struct, rather than a reference to, like, a game object or something like that. It's what's called I think it's a value type data structure versus a reference type. That's all fancy schmancy mumbo jumbo for, instead of pointing directly to the object that I'm talking about, I point to the container of the object. Now, structs are great if you want to have a data structure with a small amount of data inside of it. And structure it's just a container. It's a container for data. So structs are really nice when you want to have a collection of related information. So say you have we'll do a music struct. Well, it would be nice if I declared it as a struct first. So struct music. So in order to declare a struct, you just have to put struct in front of it, and then the name of the struct, and then some open curly braces. Now, inside of the struct, we can put all of the information that we want to have in regards to any music piece that we put in. So say we want to know what to call this music piece. We're going to have a string name. That makes sense. And this music needs audio. So we're going to also put in an audio clip into this struct. Audio clip. Or, yeah, that'll be fine. So now our music struct contains this name and audio clip variable because they are related. And maybe you want to record whether or not you want to loop the music. Maybe you just want to play it once through to the end, but never again. It's a one and done. So we'll put in our bool is looping. And I think that's good for now. You get the idea of your struct can hold a bunch of different types of variables. Now that we have all of that inside of our struct, what do we do with it? Well, I'm glad you asked. We're going to put a public music array, that's these square brackets, music, or music clips. Music clips might be better. That should work, doesn't it? Ah! I see. So, it's yelling at me because I made this array more available than I made the struct. So, we're going to need to put public in front of the struct to make it stop yelling at us. Because it would be really awkward if we were trying to access this array of music structs, but the music struct's data is private, meaning we can't get to it. It's pretty much like having a doorway open, but inside of that door frame is just a solid wall. Seems pretty useless. Now that we have public struct music and public music array music clips, we're going to save. We're going to go back to the Unity editor. Give me a second to swap over OBS. There we go. And we're going to add a new empty game object, and we're going to call it Game Manager. And because I am me, hello, I'm going to throw it to the top because it's a very important script, and I don't want to have to fight to find it. Well, it's a very important game object that holds a very important script. Or it will. So now that we have our Game Manager game object, we're going to throw our Game Manager script into its inspector. And hey, you can see our public coins. And we can modify it as need be. So now, actually, that's quite strange. It's not showing up. I think I might need to serialize field. Is that the thing that I need to do for structs? Give me just 1 second. Struct inspector. I know there's some weird thing that we have to do in order to get our system.serializable. That's what it was. Okay, so I forgot one step in order to make our struct visible in the inspector. Let's go back into Visual Studio. And we're going to need to add something above our public struct music. It's going to be a square bracket. And inside that square bracket, we're going to type capital S system dot serializable. Like that. This will make it so that the inspector can actually process and communicate to us our struct values. So once we have that, we're going to flop back to the inspector so that we can see the fruits of our labors in action. Now when we see our Game Manager script in the inspector, it has this music clips title with a little arrow next to it. We're going to hit that arrow, and it's asking us for a size. This is the size of the array of music clips that we are working with. I'll keep it to 1 for right now. This is the point where I remember that I always forget to put public whenever I want things to be public. Okay, so you see how it has element 0 but nothing there? That's because we didn't make any of our variables inside of the struct public. So let's flop back to Visual Studio for just a second. And the culprit's string name needs to be public string name. Audio clip needs to be public audio clip. Bool is looping needs to be, you guessed it, public bool is looping. Now when we go back and see our size 1 array with our element 0 now has that same arrow that music clips had. And when we click on it, we see name, audio clip, and a toggle for is looping. So you can see how you can create this really easy and dynamic system when you're working with artists or designers who don't necessarily know as much as you do about C#. You can just be like, hey, just look in the inspector. It's all there. Just work with that. It's my favorite. So now we have the Jest track. I don't have any audio clips, so sadly this will remain blank. and we'll put is looping. But yeah, you can see where you can really get some use out of working with structs, especially with your inspector window. Because that way you can just communicate, hey, this is a large amount of data that I'm going to need in order to make this system work. I'm going to expose all of that to you so you can fill it in, and then I'm going to take it in and I'm going to do stuff with it. It's the best part about being a programmer. Is just, you just gotta believe that the data will be there when you get back. Oh, I totally forgot to. It's fine. So, apologies about forgetting to switch back to Unity View. As you can see, the arrow, JS track, and as soon as you type in a name here, it appears instead of element 0. It's actually an identifier! Makes it very easy to find when you have a billion of them. Pizza track. But you get the idea. That was a little excessive, but demonstration. Okay, so let me see if I can pop open the stream chat. Yes. Does anyone have any questions on that so far? Sorry, I was totally in the wrong window. Okay, so with our last time remaining, we'll go through we're going to go back to Visual Studio, back to our game manager, and we're going to work with enums. So enums are honestly one of my favorites to work with because I just think they're so easy to read, even to the untrained eye. That's like their whole entire purpose. They're basically like an extended Boolean to save a set of game states. So like, if you wanted to say, the weather is sunny, or the door is open, or it was Colonel Mustard in the parlor with a knife. All three of those could actually be enums. Actually, that might actually work pretty well for a clue random generator. Anyways. So, enums. Let's create our own. So, enum. And we'll do weather. Yeah, makes it all nice. Now, I want to say it is... Now, this might not be the thing. Let me double check. I could just be trying to instantiate an array in a different language. As it happens. Okay. Let me doubly check this. I was almost right. I just didn't need the equal sign. Okay, so with an enum, we have enum weather, we have sunny, cloudy, rainy, snowy, hurricane, doom. Easy peasy lemon squeezy. So now when we are working with our enum, let me scroll a bit. We have this data type, this enum, defined. So now it recognizes, hey, this is a actual data structure that I need to pay attention to, rather than random ones and zeros. So let's go into start, and we'll add, we're going to add a switch statement, but first we need a variable to hold a weather enum for us. And actually, I'm going to capitalize the W because I am picky. So, weather. So now we have a variable weather to store our weather state, or our weather enum. So let's go into start. We're going to have a switch statement on our weather. So I pick a switch statement for our enum because there are only ever going to be as many cases as there are predefined enum states. So since it is only these only these 6 cases, it would be a lot more efficient for us to just have a switch. Also makes our lives a little bit easier. So for our switch statement, we're going to have a case for weather dot sunny break. And I'm going to actually copy the break statement to expedite this process a little bit. Then we've got weather dot rainy. But you get the idea. Now we have predefined, super easy to reference states that we can change the behavior of our program to suit. I'm only going to do it for these because ain't gonna nobody got time for that. So whenever you are referencing a single state of that enum, in order for the computer to recognize that it is of that enum, you need to include the name of the enum and then the state. So we're always going to be with our enums using the dot modifier to make sure that we're referencing the correct state. Double check. Okay, so with our enums set, let's see, is there an easy way to practically, I mean, if anyone knows of Zork, one of the earliest, what's it called, text adventure games, enums are pretty much how they decipher direction. Or at least it should be, because that would make it really efficient and very easy to read. Like, imagine me having to write this whole thing out. Like, what if I had to make it a string instead of our enum? Have to check if weather dot is equal, because that's the function for checking if a string is equal to sunny. But then what if it's lower or all uppercase? What if it has like the weirdest casing ever? It's just a mess. Enums make our life easy. Okay, so the last thing we're going to go over, actually, does anyone have any questions so far for enums and where they would be useful? Because the answer's everywhere. Okay, so the last thing we're going to go over is lists. Now, lists aren't a super complex data structure like the rest of that we've covered today, but they are no less useful. In fact, they are extraordinarily useful. So good. So, why would we use... Well, I guess let me define list first. A list is basically a collection of data of a single type. But yes, that's an array. Well, yes and no. A list is basically like an array, except it doesn't have a predefined size. So you know how our array in our inspector always asks us for a size first. That's because an array is always of a set size. You can't dynamically change the size of an array unless you basically like destroy the whole array. It's a mess. Don't do it. Lists, however, don't have that limitation. You can continuously add, remove, and redefine what you want in your list on the fly, in your code. It's great. So let's try making a list. Let's make a list of... Looking around my room for inspiration to strike. We'll do a list of Pokemon strings. Strings of Pokemon names. So now, in our Visual Studio, in our variables section, we are going to type out list, and then a open, it's a less than sign, I think. I was totally gonna call it like an alligator face, like in 2nd grade. Anyways, so this is a little bit different than how we usually initialize arrays, or define arrays. So, in a list, we call it a list first. Inside of these less than greater than sign, we're going to put in the type of data that's going inside of this list. So, for a list of Pokemon names, it's going to be strings. And now, of course, we need the name of the list. So, Pokemon names. I can spell, I swear. So now we have our list of type string of Pokemon names. Now, let's take a look at some of the functions that a list allows us rather than an array. So let's take out Pokemon names. And what was our array called? Music clips. We'll take some comparisons to the two, because it's always the struggle of when do you use an array, when do you use a list. So, for Pokemon names, let's add the dot operator afterward, and I don't know if you guys can see this actually, but if you had created your list and added the dot operator afterward, you would come up with a dropdown that has functions such as add, which will add a value to your list. It has count, which will count the number of items inside of your list. This is just like the array dot length, but for lists. Clear, which will, as it sounds, clear the entire list. And so on and so forth. There's also a specific, actually, we should probably go over this type of loop, but maybe not 5 minutes before the end. I did forget to mention that there is another type of loop that is super useful, especially when you want to iterate through an array. Basically, if you want to walk through all of the values in an array and do some stuff with them, you would use what's called a for each loop. Or you can also do that with a list. For each for the list is great. So, for each loop is basically for each thing inside of this array or this list, I want to do some things to it, or do some things with this value. Makes it a lot easier than having to do for int I, where I is equal to the size of the list or the size of the array, and have to do some weird math stuff. Programmers are notoriously lazy, so this is one of many ways that we have shortcuts to make our lives easier, because while we can do it the long way, why would we? Anyways, that was my aside, again. So, now that we've looked through the functions inside of the list, let's look at the functions inside of our array, our music clips array. There are less that we can see the use of readily. We have length and we have clone. Now length, as I said when we were looking at count, is basically how many things are in this array. The length of the array. Now, clone, on the other hand, I don't think I've ever actually used clone. It probably does exactly what it sounds like and create a clone of the array. Yeah. Makes a shallow copy of an array, meaning that the elements from one array are copied into another. Okay, yeah, sounds about right. So, makes a copy of the array. So, looking through all of these inside of our music clips array, it has a lot less flexibility than our list. But if we want to do something quickly and just get her done, arrays, I want to say, are faster than lists, computationally. I was looking this up the other day. Anyways, arrays are faster computationally than a list, but not by much if you're not going to be calling this off like an insane amount. Like if you're not using big data inside of your list trying to manipulate this list or array. For our purposes, it's probably going to be easier for you to use the list. I just like using arrays for whatever I want to have in the inspector, because it's very easy to initialize. And I'm also used to arrays from Java, when I had Java class. So, I think we're at time. Yeah. So, that is the end of our third Twitch Tutorial Tuesday Intro to Programming edition. Does anyone have any questions on anything that we covered today? Anything at all. I am at your service for all of the weird and unexplainable errors that come up with coding. Okay. Well, if anyone has any questions that come up that require emergency attention before next Tutorial Tuesday, actually, speaking of, next Tutorial Tuesday is actually going to be the last in this series. So, what's the difference between an enum and a list? Oh, okay. So an enum is its own data type, and it's mostly used for storing states, like different types of game states or different types of like directions, things that you would see, oh, that is open, that is closed, that is red, that is blue. And you want to have something happen on these specific states. A list, however, is any sort of information that you want to have inside of this container. Well, of a single type. There's also array lists, that'll be another time. But does that make sense? So you can have a list of like strings, you can have a list of integers, yeah, you can even have a list of enums. That would be a little weird, but you know, whatever floats your boat. Okay, so with that, next week is going to be the last Twitch Tutorial Tuesday Intro to Programming Edition. So if anyone has any special topics that they are just burning to get some answers and explanations, please don't hesitate to send me a line. My Discord is Noxarai. I am in the Game Dev Nights Discord as Jess. I am the treasurer. Hello. And yeah, I will do my best to see if I can make it happen. If not, then we're going to be going over some more interesting programming concepts, including array lists. Because array lists are fun, if also strange and wily. Alright. If no one else has any questions, have a wonderful week, everyone, and I will see y'all next week. Bye-bye!